The Republic of Iceland is a Nordic island country with a population of just over 329,000 people.
Iceland is located between the North American and Arctic Oceans and was created by the divergent boundaries of the North American and Eurasian plates.
A divergent boundary occurs when two tectonic plates move away from each other and magma forms new crust, or in this case, Iceland.
Because Iceland is located on a divergent boundary, there is a lot of seismic and volcanic activity throughout the island.
Iceland is also located on top of a hotspot, which adds to the seismic and volcanic activity in the area. A hotspot is defined as a place in the upper mantle of the Earth at which hot magma from the lower mantle upwells to melt through the crust, usually in the interior of a tectonic plate, to form a volcanic feature. This hotspot also contributed to the formation of Iceland.
This is a stratovolcano completely filled by an ice cap on the southern side of Iceland. In 2010, after a few thousand small earthquakes, the volcano began erupting. On April 14th, the volcano erupted again, which caused meltwater floods and required 800 people to be evacuated.
After the eruption in 2010, the ash cloud released caused closure to air travel as the ash spread all across Europe. This resulted in $1.7 billion of money lost for the airline agencies.
In 2011, the eruption of Grytvoten, Iceland's most active volcano, sent a large plume of dust 20 kilometers into the atmosphere. Over 2,300 flights were delayed as the ash cloud traveled across the UK. This picture actually was taken 3 months after the eruption, and as you can see, everything is still covered in ash.
In 2008, a magnitude 6.3 earthquake happened in Iceland. Although no one was killed, 30 people were injured.
On a slightly related note, a number of sheep were also killed in the incident. This had a significant impact on Iceland's economy.
The center of the earthquake was 28 miles from the capital.
Another disaster was the recent eruption of Bardarbunga in Vatnajökull National Park. This eruption started on August 31st, 2014 and continued until February 28th, 2015. This 6-month-long eruption was the biggest Iceland has had in over 200 years. The constant rate at which it was releasing lava, ash, and sulfur dioxide fumes made the air unhealthy and difficult to breathe in across the country, which, as stated before, has a population of about 330,000 people. There are no direct casualties, but this polluted air has been proven to increase heart and lung problems, which can lead to death.
Introducing the new Sanctuary Stadium. Housing 333,000 people, this wondrous stadium is a safe haven for all natural disasters. Along with its new technology, this would be a wondrous place to watch any kind of game.
A new sports stadium is greatly needed to provide sufficient entertainment and a safe haven for all those in need. Gabbro, which is a rock that is very abundant in Iceland, is ground up and used in concrete aggregate, which will be used to create the stadium itself, as well as be incorporated into the steel of the pillars that will support the stadium while it sits on the ocean.
Our first engineering concept involved seawater pumps. In the past, this was used during the 1973 eruption of Eldfell. The port town of Jaime used seawater to cool and divert lava, thus saving their ports from destruction. We have improved on this idea with the ability to transfer salt water from the Atlantic Ocean at will, using special steel tubes with gabbro incorporated into them. Similar to the way a sink works, these pumps can turn on and off at will. When a volcano erupts, these pumps can be used to cool and divert the lava to protect the stadium and the people within it.
Rhyolite is used in a variety of different cements. This is why rhyolite would be the perfect rock to use for the base/ground underneath the sod. This would allow for the stadium to be used all year round and for a variety of purposes.
The Sanctuary Stadium is also called a sanctuary due to its advanced metro system. Inspired by the Channel Tunnel that connects the United Kingdom to France, this cheaper version uses plexiglass and steel to connect the town of Selfoss to the stadium. This system can be used to evacuate citizens to the stadium or transfer people out. if needed. Due to the capabilities of earthquakes, structures falling can be an incredibly large safety hazard. This introduces our second engineering design.
This concept is our overall earthquake-proof building. We have reinforced the concrete with many rhyolite buttresses in the shape of triangles. The design of a triangle is more capable of withstanding earthquakes than other shapes, which is why it is commonly used in construction. This reinforcement will prevent the stadium from falling during an earthquake, eliminating a major safety hazard.
Our third and final engineering concept involves the exostructure of the stadium. On the roof of the building is a retractable layer of stainless steel. The roof is already made of plexiglass, but due to the potential ash buildup that could occur on the roof and therefore collapse it, we have installed this layer, which acts similarly to a garage door, to prevent the collapse of the stadium and ensure a safe environment for the people inside of it.
In conclusion, the Sanctuary Stadium will solve many problems that Iceland has with volcanoes and earthquakes. Its location, its metro system, and its three engineering concepts all come together to provide a safe haven for the people of Iceland.
Before, many sporting events were canceled due to eruptions, volcanic ash, and safety hazards. However, with the Sanctuary Stadium, year-round entertainment can be provided to lighten the hearts of the Icelandic people, and due to its vast capacity, no citizen of Iceland will be left out.